if we have this infinity n plus 1 and n I plus would be greater than for all I. So basically, in the entire series, the next term will be smaller than the previous term. So it will go something like this. Let's say the series has a limit over here. Basically, what the integral test says. Suppose there's a function called f of x where f of n, so where basically f of n is equal to a of n after some point. Let's say there's a point C such that if n is greater than or equal to C, these start becoming equal. So f of n would, for example, be like, for example, this is the function, right? And then from 2 point onwards, from this point onwards, f of n is equal to a of n. So basically we can do an integral test over here where, let me change the color. We can use the left Riemann sum and right Riemann sum with intervals of, let's say here we have, let's do 3, 4, 5, 6, 7. So the right Riemann sum would be a triangle going all the way up till here. Actually, this here, this. We are using intervals of 1. And what we are trying to figure out is actually let's do from A4 onwards. So this area over here, this area over here is A4, So A4 times 1, basically A4. This over area over here is A5. This area over here is A6. This area over here is A7, and so on and so on. So the integral from 3 to infinity or let's do k actually, would be from A4 plus A5 plus A6 plus A7 till AK. Yeah. Is that correct? Yeah, that makes sense, I guess. So A7 would be the last. Then you're finding the integral from 3 till k, and then AK would be last, and it starts from A4. Now we are going to use the left Riemann sum. You're going to do this, and then here, 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 this included, from 3. So the area of this is A3 because it's 3 times 1, A3 times 1, A4, A5, A6, and then 8. So before we concluded this, we can also say K4. So A4 plus A5 plus A6. This gives the area from 4 to 7. Or we can say from 4 to K plus 1. Right? So area from, so integral from this till 7. Sorry, not, hold on. What am I doing? It's not this. It's the left. Well, here's the right Riemann sum, so this sum would be less. Would be like this. So you have the area under the graph, and then the sum of the squares would be an underestimate. Over here, the sum of the rectangles would be an overestimate. So this would be an overestimate from 4 to k. Let's say, for example, from 4 to 7, the overestimate would be A4, A5, A6. So A4, A5, A6. If we do it till k, AK, then it would be an overestimate from 4 to k plus 1. Basically, what I gathered is this. This is called the integral test. This is k plus 1. Sorry, this is 3. Or you know what? We can write it like this. Normally when we are writing comparison, we write the lowest one first. From 4 to k1. And then for this one we can start it from 4 and then we can add a4 separately. So what I mean is, instead of from 3 we can do 4. So this is an underestimate of this area from 3 to 7, a4, a5, a6, a7. But we can add a4 separately and we can add a5, we can do the integral from 4 to k, then add a4 separately, which is what I'm doing here. We can generalize this. So let's say the starting number is I. Let's say the starting number is x. The assumption is that f of f is continuously decreasing and it matches with, it is equal to every value of a after a certain point, such that this works. Like from x onwards, f of n and is equal to a of n. F of n is equal to an. Then this formula works. That is the integral test. I used capital N here. So this is wrong. Shouldn't be a n, it should be a capital N. And so there's a mistake here and a mistake here which I need to fix.